Okay, so this is totally different. I cannot use this method, I cannot use this method, and I cannot use this method or an and. I cannot move 15 to the other side. As we know, 0 has to be on one side when we deal with quadratics. Okay, well, obviously I'm going to factor. So the first step is factor. If I can. If factorable. Not all of them are factorable. So can anyone give us the factor form of this? Excellent. In the next step, I will study the sign of x plus 5 times x plus 3. What does that mean? Okay, so let's get a chart going. If you read the book and you find a different method that you like, please use it. I prefer this one. It's easier to explain. And I always use it myself. But if you find a different method that works for you, please use it. That works better for you. Okay. Notice what I put first. Values of x. What I put next is the first factor in the problem. And then I copy the next factor in the problem. And this is the entire product, because this is really what I'm interested in. I'm not interested in any of the particular pieces, but I can't determine anything if I don't look at the signs of each piece. So x is the variable in the problem. And then in x, in here, I have to put the values that make this 0 and this 0 in ascending order. Which value makes this 0? Correct. Which value makes this 0? Good. So then they have to be -5 and -3 in this order from left to right. In this first row for x plus 5, I have to have a 0 somewhere. Under which number? I know it's silly, but I just want to make sure you understand what I'm doing. Under which number I will put 0 for x plus 5? Correct. Under which number I will put 0 for x plus 3? And now please tell me what will happen when x is -5 right here, right under -5, but for the product, and what will happen right under -3 and for the product. What do you think? No. So this is what look what, let me explain again what I'm asking. X plus 5 is 0. What will this be equal to when x plus 5 is 0? This portion is 0. X plus 5 under -5 is 0. So how much will this be? How much is 0 times x plus 3? Good. What will I have to write for the product under -3? Is that clear? Okay, when one of the factors is 0, the product will be 0, as we know from the zero product principle. Perfect. Now I'm trying to study the sign of x plus 5. There are two ways of studying or trying to find the sign. Can you imagine how I would graph this? It's a line, right? I either graph it like this, or I graph it like this. If I graph it like this, it comes from negative and goes to positive. If I graph it like this, then it comes from positive and goes to negative. How do I graph it? When do I graph it like this? When it has a positive leading coefficient. When do I graph it like this? When it has a negative leading coefficient. So do these two have a positive leading coefficient or a negative leading coefficient? Positive. So they come from negative, then they will be 0 when they cross the x-axis, and then they will be positive. Here's another way. Plug in -10. -10 plus 5 is negative. Plug in 15. 15 plus 5 is positive. Exactly what we just said. It's negative before It crosses the x-axis at -5, and it's positive afterwards. Same thing with x plus 3. It's negative before it crosses the x-axis, and it's positive afterwards. I do see 3 subintervals. 1, 2, 3. On each subinterval, I will multiply what I see. On the first subinterval, I multiply 2 negatives. What will be the sign of the product when I multiply 2 negatives? Right. On the second subinterval, I multiply a positive by a negative. What will be the sign of the product? And finally, I have no negatives. Only now, in step 3, choose the interval. I'm choosing the interval based on this. This tells me what to choose. So what sign is greater than or equal to 0? I only have 2 possible signs. Only one of them is greater than or equal to 0, right? So I see the product is positive when x is here. And again, I see the product to be positive when x is here. So if I choose x between these two, union between these two, the product will be positive and the condition will be fulfilled. If I choose here, that will be wrong because the product is negative, so the negative will not be greater than or equal to 0. So then the solution is x in the interval, negative infinity, -5. There is equal symbol here, so close, union, -3 to infinity, and close at -3. This is the way we solve quadratic inequalities. I would like to make one up, which will be a polynomial. Here it is. X, -x minus 3, x minus 4 less than or equal to 0. How many factors we see in this problem? I already gave it to you factored. We didn't have to factor it. It was already given to us in the factored form. So how many factors I see here? Careful. 1, 2, 3. The degree is 3. Okay. X is the variable in the problem, but the next row is the first factor. I have to put x and study its sign. Then I have -x minus 3. And then I have x minus 4. And I'm going to put here the word product because I don't have enough room to put the whole thing. But by the product, I mean the whole thing. I need to determine the zeros. Where is each and every factor 0? Can anyone give them in the ascending order to us? When is this 0? Yes, when is this 0? Negative with plus, no, it's not going to work. He has -x minus 3 equals 0, and I have to move x or move -3. -x minus 3 is 0, -x equals 3, x equals -3. So 0, -3, and? Good. So -3, 0, and 4. Tell me, where do I have a 0 for x? Under which number? Perfect. Where do I have a 0 for -x minus 3? Perfect. Where do I have a 0 for x minus 4? Now what happens to the product in all these 3 situations? Very good. If any of those factors is 0, the product must be 0. We know that from the zero product principle. Can anyone give us the sign for x? Linear function with a positive slope. What will be the sign? Looks, if you graph it, looks like this. It crosses at 0, but it's negative before it crosses. And it's positive afterwards. Or plug in numbers. If you don't want to think in terms of the graph, plug in numbers. Take a number between this and plug it in. Take a number between this and plug it in. You don't have to think in terms of the graph. I think it's easier if we think in terms of the graph, but you don't have to. Now, can anyone give us the sign for negative x minus 3? Plug in a number to the left of negative 3. So if you plug in negative 100, negative 100 times negative is 100. 100 minus 3 is positive. Choose a number between negative infinity and negative 3. Negative 100. Negative 100 with minus in front is 100. 100 minus 3 is positive. Is that okay? So these are the same, so it has to be the same sequence. Is this okay? How many subintervals I see? I see 1, 2, 3, 4. 4 subintervals. What is the sign of the product on the first subinterval? You don't have to count the positives, only count the negatives. 2 negatives will always give us, when we multiply or divide them, they will always give us what? Very good. Now I have 3 negatives. In the next subinterval, what is the sign? In the next, very good, excellent. In the next subinterval, I have 2 negatives. And in the last one, I have 1 negative. Only now, I'm looking at this, and I'm asking myself, which sign is less than or equal to 0? And the answer is there is only one sign that is less than or equal to 0. Negative. So let's look at the product. Is the product ever negative? It's negative here for this, and it's negative here for this. How do I write the solution? That's it. That's how we solve polynomial inequalities. You're not responsible for rational ones, but I can show you examples later next week. I would like to finish this with graphs. We're finally ready to graph the quadratic function. So 11.5 and 11.6. Graphing quadratic. Yes, please.
It's never going to come up if we can't factor it. Like, go back.
If you cannot, that's a very good question. Thank you. If you cannot factor it, you have to use the quadratic formula to find the zeros, the solutions. Very good question. Very good question. So if the polynomial is not given to you in the factored form and it's not factorable, then you have to use the quadratic formula, find the zeros, and then put the numbers up here, and then 0 under the number, whatever the number is. Yes, that's the only difference. Thank you for asking that. Thank you. Okay, here's the two forms of the quadratic function. And this is very familiar, right? Because if I said this equal to 0, is the quadratic equation. This second one is not familiar. We haven't seen this yet, and I will talk about it. Explain what it is. So a quadratic function can be given to us in this form or in this form. They both mean the same thing. Let's start with the first form. I'm going to pick a function, a quadratic function like f of x, let's say, equals x squared plus 6x plus 8. And I'm going to graph it. Graph f of x. First question for you is, what type of function is it? Of course, it's a quadratic equation. We do know 3 functions, actually 4 graphs so far, right? We know this graph, or this graph, which is very good. We know this graph, very good. We know this graph, excellent. And we also know this graph, much friendlier. Same thing, but with an odd index. Exactly. Now we're adding the 5th graph to our list of graphs. The graph of a quadratic function is a parabola. The graph of a quadratic function is a parabola. The parabola is a symmetric graph. Symmetric graph with respect to its axis of symmetry. How does a parabola look like? Here's how it looks like. It can open upwards, or it can open downwards. Where is the axis of symmetry? If this is the minimum, this is the maximum, it's always the vertical line, which is not part of the graph. Notice that I have not graphed it as a solid line. It's part of the graph. It's not part of the graph, so we don't graph it as a solid line. This is the axis of symmetry. It's the vertical line passing through this point that is called vertex. If it's a minimum or a maximum, it's still called vertex. So the parabola is a symmetric graph, symmetric with respect to its axis of symmetry, which is a vertical line passing through the vertex. When I'm asked to graph a parabola, I have the following steps to follow, to go through. Shape, meaning if it has a minimum or if it has a maximum. And you can say, how can you start with the shape when we haven't graphed it yet? I have to start with the shape because I want to make sure that I don't make a mistake down the road. And I do know the shape. If the leading coefficient is a positive number, like here, the parabola has a minimum. In this case, the leading coefficient is 1. Therefore, I know the parabola has a minimum. If the leading coefficient is a negative number, then the parabola will have a maximum, like in this situation, in the second graph. So leading coefficient positive, parabola we know for sure it has a minimum. Leading coefficient negative, we know for sure it has a maximum. Okay. So in this case, I know it's this. It will have a minimum. Step number 2, the vertex. Here are the coordinates of the vertex. The x coordinate of the vertex, very easy to remember. I'm going to put on the side the quadratic formula. So you can relate the x coordinate of the vertex is this, negative b over 2a from the quadratic formula. How do I determine the y coordinate for any function if I have x? What do I do with that x? If I'm giving you a function, I say x is 5. Find y. What will you do with 5? How will you find the y coordinate? If I say x is 5, what would you do with that? Exactly, plug it in. Of course. So this is f of whatever this number is, of negative b over 2a. So let's find the vertex. I start with finding the x coordinate. Negative b over 2a, negative. How much is b? How much is 2 times a? Very good. So then how much is x? Perfect. So I have the vertex with the x coordinate of negative 3. Again, how do we find the y coordinate? Good. So let's say f of negative 3. Of course, you can put in the graphing calculator if you want to, or negative 3 to the second power is 9. Negative 3 times 6. Good. And plus 8. Excellent. So this is 17 minus 18. It's negative 1. So in step 2, I was able to determine the vertex. Moving on to step 3. Any questions? Say it again. But if you remember the quadratic formula, you'll have no difficulties. And we need to know by now that we plug in the function to determine the y coordinate, right? Yes, we have to build on what we know. Yes. Okay, 3. X-intercepts, and in parentheses I will say, if they exist. What does that mean? Okay, so does this parabola have a minimum or a maximum? What did we establish? Good. So in our case, remember we are graphing this parabola. So in our case, the parabola has a minimum or a maximum? Minimum. So let's discuss here. So this is a discussion. Okay? I have to deviate for a second from what I'm doing because I need to discuss this. So the parabola, so the absolute value is this, the parabola is this, right? So in how many ways can I graph a parabola? And there are only 3 that has a minimum. There are only 3. This is one option with a minimum, correct? This is the second option for a minimum. And this is the third option for a minimum. Does this remind you of anything that we discussed today? How many solutions are here for how many times does the parabola intersect the x-axis? How many x-intercepts does it have? None. Very good. How many does it have here? 1. However, it's a double solution, right? Because it's quadratic. And how many here? Called distinct real solutions. Does this ring a bell? What is it? The discriminant. So the discriminant b squared minus 4ac must be what type of number here? Careful. If it's positive, then I have 2 real solutions. But exactly, there are no solutions. Good. What about here? B squared minus 4ac must be? Absolutely. And here, b squared minus 4ac must be? Absolutely, because it has two distinct real solutions, one solution, but we know it's a double, and no solutions. So I don't want to waste my time. If the x-intercepts don't exist, like here, I don't want to waste my time. In this situation, the y-coordinate of the vertex must be what? It's on the x-axis. Exactly. Do I have that situation? No. So the y-coordinate is not 0, so it's definitely not this one. The could it be this? Or could it be this? So let's look at the vertex. Where will you plot the vertex? It will be -3, -1. So is it this situation or is it this situation? Of course. Because the y-coordinate of the vertex is not positive. The y-coordinate of the vertex is negative for a minimum. We're only talking about a minimum here. So will the x-intercepts exist? Of course. So I have to find them. So all this analysis is in the background. So when I see a vertex like this and I know it has a minimum and the minimum value of the function is -3, then I know it has to cross the x-axis. But if I had the vertex -3, 5, I would say, no way, I'm not going to waste my time because it's up there. It doesn't touch the x-axis. It doesn't cross the x-axis. But in this case, the x-intercepts exist because it's this case. So how do I find the x-intercepts for any function? That will be the y-intercept. So in step number 4, y-intercept. You want to do that first? That's fine. X equals 0, so I have to find f of 0. So how much is f of 0? Careful. Exactly. F of 0 is 8, so what is the ordered pair? Good. So we found the y-intercept, but I still haven't determined the x-intercept. Say it again. Exactly. So y equals 0, so what do I write?
0
Yes?
equals
Yes?
x squared plus 6x plus 8.
Indeed. Well, I've reviewed factoring. If I can factor, I will use a quadratic formula, but I chose a simple situation. So what is this?
X plus 4x plus 2.
So the options are,
-4 and -2.
that's it. So the ordered pairs are,
-4 is
good. Now 5 and 6 are just words, but I have to write them, and you'll see how important they are when we get to the next example with a word problem. What is the axis of symmetry? Axis of symmetry is, remember, it's the vertical line passing through the vertex. Imagine the point -3, -1, and tell me what vertical line passes through the vertex. That will be a horizontal line. You're on the right track, though. That will be a horizontal line, and that will give us the minimum. Exactly. X equals -3 is the vertical line, the only vertical line passing through -3, -1. And what you just said is my next question. Since this function has a minimum or a maximum again? Right. Can anyone give us the minimum possible value of f of x? Is how much? I just want a number. -1. Is that clear? Okay. Now I have all this information. I'm ready to graph it. It took us half an hour to do to graph or gather the information for the first one, but all the rest will take 3 minutes because I needed to explain all these steps. Okay, I must start with a vertex, which is -3, -1, right here. I have to continue with the axis of symmetry, which is not part of the graph. The vertical line passing through the vertex. I have to continue with the x and y intercepts. Now, pay attention here to one thing, please. The graph is symmetric with respect to this line. If I plot this point here and this point here, I know something is wrong. They have to be, in this case, both of them 1 unit away from the axis of symmetry, or 2 units away, or 10 units away, but symmetric. So if I put this point and then the other one is -7, then I say, whoops. Okay. And now 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Try to make it not too acute at the vertex. And as symmetric as possible. I'm not going to look with a magnifying glass. So this is f of x, which is x squared plus x plus 8. Can anyone give us the range and the domain? Of course, the domain is very clear. It's a polynomial function. What is the domain? For all polynomial functions. Yes, all real numbers. And can anyone give us the range? Even I should have asked you about the range even before we graphed it, because we already had it in our head, the picture of this graph. So what is the range? Exactly. Must be. We'll graph some more, but I like to look at a word problem. And then we come back and graph some more. On page 704, let's look at 58. We already had a problem with quadratic function 2 minutes ago, the one with the Wi-Fi. Okay. The Utah Ski Club sells calendars to raise money. The profit P in cents from selling X calendars is given by the equation. So X, number of calendars. P of X, profit in cents. So 360X minus X squared. First question. Find how many calendars must be sold to maximize profit. And then find the maximum profit. Let's look at this function. What type of function is it? Quadratic. Very good. Of course. That's what we are discussing. Next question. Does it have a maximum or a minimum?
Maximum.
Right. It's not arranged in descending order, of course. They will always try to trick us. So the function is basically this. That's why when we reviewed chapter 6, I said descending order all the time. Yes, indeed. Perfect. Okay. So then, this function is quadratic. It has a maximum. We're asked to find how many calendars they should sell for attaining that maximum, obtaining the maximum profit. So, what do we know about a quadratic function? That has a maximum. How do I determine, or minimum, but in this case it has a maximum. How do I determine the maximum? What point needs to be calculated or determined in order to find that maximum? That point is called, exactly. There is no other function that has vertex, only quadratic. How do I find the vertex?
Like X-intercepts.
There is no need for the x-intercepts in order to find the vertex. Exactly, negative b over 2a. Negative, how much is b? How much is 2 times a? Perfect. What is the answer? What? Right? This is the x. X is the number of calendars. Now the question is, how do I find the profit? So negative 180 squared plus 360 times 180. I plug it in the graphing calculator. So I have negative 180 squared and plus 360 times 180. And I got 32,400 cents. Or if you want, $324. Does it make sense? It's only because the function was quadratic. Okay. The cost C in dollars of manufacturing, let's do one more, 57. And then we go back to graphing. The cost C in dollars of manufacturing X bicycles is given by the function C of X, 2x squared minus 800x and plus 92,000. First question. Find the number of bicycles that must be manufactured to minimize the cost. And find the minimum cost. What type of function is this? Good. Does it have a minimum or a maximum? Good. How do I find the minimum? Of course. Is the quadratic function arranged in descending order because I don't want to make a mistake? Yes. So negative outside. How much is b? How much is 2 times a? And how much is the answer? How many bicycles they should manufacture? It's x. Perfect. 200 units. And now, how will you advise this the manufacturer, the owner of the factory? You'll say, you have to manufacture and sell, because if you just manufacture them and you don't do anything with them, you just keep them, you're still minimizing your cost, but it doesn't mean that your profit or revenue will be there, right? So you have to manufacture 200 in order to minimize your cost, and she is going to ask you, okay, how much what will be my minimum cost? How will you determine the minimum cost? Yes, C of 200. So 2 times 200 squared minus 800 times 200 plus 92,000. I put in the graphing calculator, and I have 2 multiplied by 200 squared minus 800 times 200 and plus 92,000. I got 12,000. So the minimum cost will be 12,000. I would like to go back to the graphing calculator for a second, because I want to show you how to plug in the graphing calculator, that function, and check your answer for the function that we just determined. So here it is. Where is it? Right here. Okay. Go to y equals, clear. And we have x squared plus 6x and plus 8. Let's go to zoom after you plug in x squared plus 6x plus 8. Let's go to zoom. Ready?
I don't remember where X is.
Oh, right here, right under the mode, right here where it says x, t, theta, and n. Right here between stat and alpha.
I'm gonna get my kid to give me a tutorial.
That's okay. Okay, so now I would like to press on zoom when you're ready. Zoom. And I would like to use the standard viewing window, 6. 6, standard. Press on 6 and let it graph. It will not graph the axis of symmetry. That part it will not graph for you. Okay, so I see it crosses the x-axis in these 2 points. Let's say I don't know what they are. I do know what they are. What are they? -2. Okay, so here, let me show you how to determine one of them. You can determine both like that. Let me show you one. So second and calc. Calc is 1, 2, 3, 4. The fourth under the viewing window, but with the second key. It gets activated with the blue key. Okay? I'm looking for the 0 of the function, where the function is 0, right? That's how we determine the x-intercept. We set the function equal to 0. So I want 2. You either go down and scroll to 2 and press enter, or you just press 2. Now you notice the graphing calculator is asking me for a left bound. The calculator doesn't know if I'm looking for this x-intercept or this x-intercept. So I have to tell the calculator where to look. So I see this intercept here. I don't know exactly what it is, but let's say. But I see that this is -4, and I see that this is -3. So I will put in a left bound of -4, -4, and enter. As you see the graph, oh, it was -4, I'm sorry. I have to go back, sorry. Let's start from the beginning. Second and calc, I don't want to put the number because I want the calculator to give us those. It was -4. Okay, so I want the left bound of -5, -5 and enter. As you see the calculator puts some limitations. This is the left limitation if you want. It's called the left bound, where the calculator will determine the 0. Now I would like to put -3 as the right bound, and you see what happens. So between these 2 vertical lines, the calculator will determine the x-intercept. Without giving those bounds, the calculator doesn't know where to look. Now it's asking us for a guess. I know the answer, but I don't want to guess. I'm going to press enter. And the calculator will give us that intercept. It will say x is equals -4 when y is 0. If I want to determine, it will never give us the y-intercept though. But if I want to determine the other one, I'm going to say between -3 and 0, let's say. So with second and calc, I'm going to look at 0 again with 2. I will put the left bound, -3. I will say the right bound is 0. And after you press enter, you see again the calculator is giving us a range. I shouldn't say range, it's not range, it's domain, but a range between this and this where it will determine the x-intercept. I don't want to guess, so I want to press enter. And it will give us the -2, 0. One other thing that I would like to show you is, I still have a minute, yes. I want to show you how to calculate the minimum with a graphing calculator. It has a minimum, correct? Okay, so let's go to second and calc again, on which option I will pick from there. Of course. So we'll press enter and it will ask us again for a left bound and a right bound. So now I will give the left bound -4 and I will give the right bound -2. So -4 enter, -2 enter, and the calculator now knows where I'm looking for a minimum. So I'm looking for a minimum between -4 and -2. I don't want to guess. Just give me the minimum. So I pressed enter. This is the error or called tolerance of the calculator. So you may always find some little error. It's negative 3.000002, but we know it's negative 3, comma negative 1. So do not entirely and 100% rely on the graphing calculator. So you see, calculator is not perfect. Okay, I like to graph one more function, and then we can stop. And the only thing that I have to show you on Tuesday, and I'm hoping you can make it on Tuesday, I just want to show you one more thing, the other form of the quadratic function. And we are done with chapter 11. And I would like to review. Okay, so let's graph one more function. Let's say 39 on page 703. So we have f of x equals negative 2x squared plus 12x. So we want to graph this function. First step. There are 6 steps. I will mention them on the test. I will say graph the quadratic function showing blah, 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 all 6. But we should know them. So number 1 is the shape. So in other words, I'm asking you, does it have a minimum or a maximum? And you can say, why are you starting with this? I'm going to see what it is when I graph. True, but if you know from the beginning, because I've seen it in papers and tests and so on and so forth. Students graph something like this, but they end up showing a minimum. I don't know how, right? So I want to avoid that situation. So is it a maximum or a minimum? Yes, it is a maximum because a is negative 2. Perfect. Number 2, I'm asked to find the vertex. I have to find the vertex. Good. So how do I find the vertex? Always make sure that the quadratic function is in descending order. Otherwise, you will identify A, B, and C wrongly. Incorrectly. So minus. B is? Good. 2 times A is? Good. So the answer for the x-coordinate of the vertex is? Careful. There are 2 negatives. I can get a negative. Good. How do I determine the y-coordinate? Very good. Excellent. F of 3. So negative 2 times 9 plus 12 times 3. Negative 2 times 9 is negative 18. And plus 36. And the answer is? Very 18, right? Very good. Number 3. X-intercepts. Do they exist? I know it would have a maximum. If the y-coordinate of the maximum is positive, the intercepts exist. If the y-coordinate is 0, it's the same with the x-intercept. But if the y-coordinate is negative, it's way below. It will not touch the x-axis. Which one is it? It will? It will or it will not. But remember, this is a maximum. It's a maximum now, and the y-coordinate is positive. So it will. Very good. So how do I determine them? Say it again. I already found the vertex. How do we find the x-intercepts for any function? Correct. So then negative 2x squared plus 12x equals 0. Factors simplify. I will simplify dividing both sides by 2. Very good. Excellent. Including the negative leading coefficient. Very good. So this is x squared minus 6x equals 0. We know we're not allowed to divide by x, and we didn't. But now I have to factor out x, and I have x minus 6. And I have two options, x equals and x equals. From the first one and from the other one. Good. So what are the two x-intercepts? 0, 0, and right, be careful, you cannot combine them. Good. So there is no point in trying to find the y-intercept, because I already found it. It's right here, 0, 0. So the y-intercept when x is 0, y is 0. 5 and 6 are only words, but I would like you to dictate those words to me. Very good. So the axis of symmetry is x equals the x coordinate of the vertex. It has to pass through it's a vertical line through the vertex. And the maximum value? Very good. I start by plotting the vertex. So 3, 18. I'm having a little trouble here. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 18. So here it is, the point. 3, 18. I have to continue with the axis of symmetry. It will help me, it's not part of the graph, but it will help me keep the graph in shape. Then I continue with 0, 0, and 1, 2, 3. Are they symmetric with respect to the axis of symmetry? Yes. And nothing else. Here it is. So this is the graph of negative 2x squared plus 12x. Can anyone give us the range? Yes, negative infinity to 18. Very good.